Hi, my name's Sylvia Martinez. I'm with Constructing Modern Knowledge Press, and I've had the pleasure of editing Ken Kahn's new book, The Learner's Apprentice, AI and the Amplification of Human Creativity. We're going to talk to Ken today about his book. So welcome, Ken.
Thank you. Yeah, looking forward to this.
So why don't you tell us a little bit about yourself?
Sure. So my interest in computers and AI goes back over 50 years. I was a really avid science fiction reader back in high school. And in college, I started taking lots of computer programming courses and took an AI course and ended up managing to get into the MIT AI lab at graduate school. This would have been 1973, 150 years ago. One of the people I met right away was Seymour Papert, who was leading the logo group. And you have to imagine what the early 70s was like, where there was no personal computers. People thought of computers as big boxes that cost millions that only experts. And he had the idea that we should make these available to all children, and not just available, but that they be available in a way in which the children could creatively take control of their computers and have them create art and music and robotics, all sorts of things. So it was a very radical idea that appealed to me. One of the reasons it appealed to me was that I saw computing as being such a kind of a enabling, creative, almost magical thing that you could have an idea, turn it into a program, and it comes alive. And I got excited about the idea of sharing that with children. So while I was doing my PhD at MIT, I spent a good fraction of my time with the logo group and working with kids, but also constructing new kinds of languages that would make it even easier for kids to not just create programs, more complicated ones, even ones that had some AI as part of the program. And then the rest of the time I was doing more ordinary AI research. Back then, symbolic AI, where you handcraft programs to do all sorts of things. First project was to come up with an expert that knew about time, but then for my PhD thesis, I created a system that took story descriptions that can make very simple animations, like you tell a story of Cinderella and a little triangle tries to meet the prince as a circle and the stepmother square gets in the way, that kind of very simple, but it was underlying it, there was some really pretty good thought processes that had been programmed. So that was always my idea of AI until a few years ago, because the idea that you think about how you might create something or how you might reason about something and then create a program to do that just seemed the much more direct, more likely to succeed way than the alternative, which is the one that has succeeded in the last 10 years, which is you don't tell the computer pretty much anything. You just give it huge amounts of data and let it learn from the huge amounts of data. And that wouldn't have been practical back, not only when I was a graduate student, but even say before 2000, because you would need huge amounts of data, you need huge amounts of computation to just the hardware and the data just weren't available.
So
But
let me see if I understand the difference,
okay,
because I think
sure.
you're making an important distinction. The way that people thought that AI would work is that we would teach the computer how to think like a person. But it turns out that this generative AI is doing something completely different. We're not telling it about how to think, we're just telling it about the world. And somehow, with all its processing power, it's coming up with these generative ideas and stories and things that seem like it's thinking. So
Right.
that must have been a big switch for AI research, and it just happened.
Yes. As a matter of fact, people point to 2012 as the turning point because that year there was an annual contest where the computer's task was to given hundreds of different images to say, oh, that's a dog, or that's a waterfall, or that's a car. And it had always been that handcrafted symbolic traditional AI programs that people had written were always doing the best. But that was the year when an AI program that was just completely trained on data did much better. And people started to realize that it could do more and more things just by giving it data and letting it learn on its own rather than trying to teach it directly or trying to reconstruct thoughts as we imagine. Personally, what happened was that in 2016, I became involved in a big European project called eCraft to Learn. And the idea was to combine maker movement and craft and AI to enable children to be able to create really interesting artifacts on their own. And my role was to make it so they could add AI to their projects. So that fit very well with my earlier interests of trying to make it easier for kids to include AI in. So I started with using the Snap blocks programming language that's should have been called Scratch Senior. I added over 100 blocks that would do speech recognition or vision recognition or even some machine learning, and worked with kids to have them create interesting little apps, took advantage of AI capabilities. But it was still very much the idea was that the child was doing all the programming. I was just giving them much better tools for doing it.
Hmm.
And it was only about 3 years ago when I started realizing that ChatGPT and even the little bit earlier version of GPT could actually construct programs in response to a conversation, that I started getting less interested in those efforts and more thinking, what does this enable children to do? Does it enable them to be, even more creative and to create even more impressive apps and be able to do this without first learning lots of technical details? So I got more and more excited about this, and I started just doing lots of little projects that were, 1 or 2 day ones, and writing up a little blog post about it, announcing on LinkedIn or Facebook or something. And I've been doing that for a couple of years when Gary Steger approached me nearly exactly a year ago and said, could I imagine putting all these things together in a book? And that's the start of the
That's when
Learner's
we
Apprentice.
started working together.
Yeah, yes.
I remember you showing me some of your work, and I'd never seen anything like it before. And that's what I want to talk to you about today is when I've read other books about AI in education, they're very focused on what teachers can do. You can make lesson plans, or maybe students can complete assignments, the kinds of assignments we've always asked kids to do, write an essay, explain the 5 causes of World War II, things like that,
Right.
that AI can completely replace. And then people worry about cheating. If kids can just go to AI to do their assignments, what's the point? And what you were presenting was something completely different, where AI is an ally. AI works side by side to create things that the student needs to do their work, which what you said about the original AI lab, it calls back to that, this constructivism where you're
Yes.
constructing things in your head that are made real in the world. And if AI can help you do that, then that's calling back to why we think it's important for kids to code, why it's important for kids to engage in projects, that they're constructing their own understanding of the world. And I think that's difficult to think about if AI is doing all the thinking for you. So I
Yes.
want to
Yes.
talk to you a little bit about how the book is constructed to help teachers see the possibilities of this creative, constructive use of AI.
Right.
In the book, there's 3 sections about creative applications of AI. One is making software, programming, making apps.
Mm-hmm.
One is about stories and storytelling. And one is about interactive adventures, choose your own adventures, old-fashioned text adventure games. And so I think that it's probably easiest to understand the learning adventures, but I think the most revolutionary part of the book are the apps. So why don't we just jump right into the most cutting edge stuff that's in the book, which is how students can create apps without learning to code.
Right. Okay, I'll share the screen here. Okay, I started with the chatbot logs, which is the online appendix to the book, where there's hundreds of links to different apps and stories, and many of them are connected directly to the book. But just to answer your question about get a sense of what it's like to create something. Here we are at Claude.ai, and you could use ChatGPT or Gemini or several of the other ones. This one has a little bit nicer interface and is a little bit better. So I typed, please create a web page that makes up nonsense words. And if I hit enter here, what's interesting is it's not only going to write the code, as it's saying here, and it's displaying it here, but it's also, as soon as it's finished generating the code, it's actually displaying the app. So now if I click generate new words, we see the words that it generated. And if I was curious about the code or trying to learn programming, I could scroll to the part where there's the JavaScript, and you can see it's come up with different kinds of syllables and how to combine them. And to generate the word, it picks a random prefix, a random middle, and a random suffix and combines them. So nice little app. And presumably every time I click, it'll create different ones. And if I go back to the chat, I could say, can add speak the words. So an important point here is that the way in which almost all the apps that I've created, and I've created hundreds of them, is I start with the simplest version I could imagine, and then I start asking one by one to add new features. So now if I click on generate new words.
Glingish. Glizish.
Hopefully you're hearing that.
We hear it.
Good.
Okay, so let's just hang on right there, because
Okay.
you first typed in, make me a web page that speaks nonsense words, right? What exactly did you type in?
Yeah, here it
Please
is.
create a
Please create a web page
nonsense
that makes
words.
up nonsense words.
And that's it. That's all you typed.
Right.
What it did was create HTML that the code that you're looking at with a browser. So you could open that same file with Chrome or Safari or whatever browser you like,
Right.
and it would do exactly the same thing.
Right. As a matter of fact, there's even a publish button here. And if I click on publish, and then I've got a new link. So if I go to a new tab and I paste it in, I could share this link with people, and then they could run the app and stuff.
Blog gang.
So then
Plethora.
you typed in, make it speak. You didn't tell it how, you didn't explain speech synthesis, you didn't explain any of that. And the code changed to make it speak the word. You didn't have to write the code. You didn't have to understand the code. It was enough that the chatbot understood what you were asking for.
Exactly. And it knew how to use this browser capability called speech synthesis utterance. And it generated this little bit of code here that it knew how to do. So, high school student that knew some programming and learn Python or JavaScript, they wouldn't necessarily know all these different libraries and all these different things. And learning them takes quite a lot of effort and time. And instead, I was able to, but I think the right way to think about this isn't just you get an app from asking for it, that you keep evolving it. I'll show you later some more examples, but maybe I'll do one more here.
Sure.
Just to give you a sense of how, so I could say, speak Gettys, I don't know. Now you're going to learn how bad I am at spelling.
Gettysburg.
Address where every third word is random generated. And if I felt better about it, I could click here and
you could fix it, but it'll probably understand.
But no, it won't care. Yeah, it does. You can be really sloppy. So we're seeing the code, and as soon as it finishes generating the code, it will display the app. Or I guess I was in the, here it is. So we can listen to it while we. Aha. So we might actually be finding an example where it did what I asked, but I'm not hearing anything right now. And I don't think this is the right time, but there's a whole sections of the book talking about troubleshooting and how to deal with debugging. Because debugging is not just fixing annoying problems. It's a great way to learn better what's going on, how to track down problems, how to do it. And what's different here is that you're doing it together with Claude or the chatbot. I can say here something. This is what you should always do. It is working, except I don't hear any. Click the speech button, and it'll try to fix it. No, because I've given it some feedback as to what was the problem. By the way, I've done this example a few times, and every time it has very different ways of generating random words. So it's interesting that how different even a task like that could be. So it talks about all the improvements and so on. Let's see if it does anything. Well, this is probably not the time to debug this, but
We
at
may
least it's
just,
got
yeah,
most of the way. And we heard it earlier being able to say
right.
these nonsense words. All right.
So let's talk a
Maybe
little bit about why you asked it to make a web app, because I think that's a very important thing for schools and in thinking about how these artifacts are created.
right. So web apps are both extremely easy to share. If you didn't have a feature like Claude has and ChatGPT now has, where you could actually publish anything you create and you have a unique URL that you could just send to people. But even if you didn't have that, you could just download it into a file, and that file could send to anybody, and any browser then could open that file, display it, and run the app, so that you get a way to distribute things to everybody without them having to install special software or libraries or anything. And
Which is very important in schools, because if your students are able to use a browser, that means they can open an HTML file. And that's all this is. You don't have to configure it to be able to run Python programs or do any kind of special get around the security that's already implemented. You can run it on a Chromebook. This makes it very versatile in schools and very secure.
yes, the security is important too, that the browser, because nobody wants visiting a web page and it starts to read your files or modify your computer. The browser's always doing things in a sandbox that's very safe and secure, because that's necessary for all the other things that the web is used for. So it's just as true for apps that you create in this process, so that they can't really do nasty things. It's very easy to switch between a browser at school, and you could now go to the library or go home and continue your project, continue your work.
So I think one of the things that I was confused about when I first started talking to you about this is I thought you were advocating that kids learn to code HTML pages, but that's not
Right.
exactly what you're talking about.
No. So that's not the focus, especially the HTML, the part inside of HTML, which is the JavaScript. That's the interesting programming language. That's not a requirement for kids to do this. It's if kids are curious, it's all sitting there able for them to not just read it, but to actually ask some questions about it. You could say, how does the generate function work? Show it to me. So it'll take this little piece of code here, and it's adding lots of comments explaining in detail how this whole thing works and giving some examples and talking it through, so that anybody is interested in learning programming language, this is a great way to do it. But it's not a prerequisite. You could go really far, create all sorts of things without ever looking at this code and just sticking with the apps that you create.
And so you're not advocating that kids learn to code this way, but it's a way for them to make interactive things that are fun and interesting or sometimes educational.
That's the main focus, but I'm not really excluding the idea that kids that want to could be even writing some of the code. The
Mhm.
chatbot writes some of the code. They go back and forth. The chatbot maybe gives comments on the kid's code. You can be a both situation, but I think the main
You could
message is how far you could get without knowing anything about the programming language.
if you were teaching a programming class and you wanted the kids to learn Python, you could ask the chatbot to write a Python program, right?
Exactly. Yes, yes. I could right now even say, well, I don't know. I could
We'll see.
show me the generator in Python or something. So it'll rewrite it in Python now. So here's the Python equivalent. It's not so different, but
But it just makes it's not quite as easy to open it in a browser and see it
yeah,
as
and share it and so on. And
right.
in some of these chatbots, it's hard to test it or run it. Though ChatGPT recently did make it relatively easy to run either JavaScript or Python in the conversation. But if you run it and it needs to do anything graphical or any complicated interface, it's a very constrained Python because many of the libraries just aren't available. But in a web app, all libraries on the web are available because the HTML could just say load in this library and it just does. You don't have to do any installation or anything. So
It'll do things like make charts and graphs with interactive sliders and all kinds of interesting mathematical representations of that you want kids to understand. So do you
yes,
have
yes.
something to show that's like a simulation?
Yeah, I've got simulations. Well, here's a fancy one that this was created completely with talking to ChatGPT. This is using the real data that NASA provided of the TRAPPIST solar system. And these are the planets. And if I click on one, it displays the data that came from the NASA site saying this is planet C and it takes 2.5 days to go around and it's this close to the sun and it's practically the same size as the Earth. While this other one here, I don't know. But I should explain too that the process of creating this was very incremental. We started off with an imaginary solar system with just one planet, one star, and then we started getting real data and making it 3D and getting the lighting because this is actually close to the color of the real star here. And notice that it lights up the planets.
Yeah.
And then after it was all working, I said, "Could we navigate?" And it said, "Sure." So then it added this thing where you can zoom in and look
Wow.
at it from different angles and stuff.
So you
So
just said add camera and it just did it.
yeah, the truth story is I said add cameras and it did it in a little bit of a buggy way. So it took 2 or 3 back and forths saying, well, this isn't quite working. Or in one case, it actually got it working, but I didn't even know what the controls were. So as a matter of fact, it added this. I said, could you make an about box? And it made this little about box that
Nice.
describes how to do it, how to rotate, how to zoom, how to pan. And it makes a little description of what it's doing and stuff. So I just asked for this and it wrote the instructions.
So these kinds of
No.
simulations that any student could make with a chatbot partner, and now chatbots can go out on the web and search for things like data, NASA data, and things like that.
Yes. When I did this almost a year ago, I did find the web page with the NASA data and pasted it in and said, "It's this data." There's a funny story about this too, which is it was all working. And then when I said, now use the real data, the planets weren't moving. And I kept saying, but the planets aren't moving. And it said, oh, I'm so sorry, I'll fix it. And then the planets aren't moving. And it says, oh, I'm so sorry, I'll fix it. It has this tendency to think you're right all the time when you're not. And after a few rounds, it said, let's try adding a time dilation feature so that the simulation will run 100 times faster. And I said, no change. And then it said, well, try a bigger number. And I tried 10,000, and this is what we got. What had happened was that the original simulation, the planets take whatever, this is 9 days to go around. So it would have taken 9 days of watching the screen to see the planet make one revolution around the sun. So it was moving, but it was moving less than a pixel every minute. So I thought it wasn't working.
But the chatbot was saying, "Oh, I'm so sorry. Let me fix it for you."
Yeah. That's one
Sometimes
of
they
the
get a
flaws that
little,
chatbots have, that they're a little bit too willing to think that the human is right.
maybe that's a good thing.
Yeah, maybe,
No.
but when it's a technical thing like this, maybe less so. But yeah,
So, in thinking about the kinds of school assignments that a student might be given, there's no cheating possible here. This isn't something where a student can do this without really thinking through some of the problems and some of the what they want to see. And if they were to cheat somehow, the logs are available of what the student has done that the teacher can look at.
that's right. That's right. So another thing I should say about this, there's a few cases of this described in the book, where the student actually initially didn't have an idea of what they wanted to do. And a chatbot had been instructed with a little guidance at the very beginning to say, if a student doesn't know, ask them what their interests are, and give them suggestions and guide them a little bit. I role played many of the examples in the book. I role play a student, different ages. And in this case, I was thinking of a high school student or a late junior high who was interested in astronomy, and then the chatbot makes a suggestion, and I say, no, that isn't very exciting. I want to do something with exoplanets because I've heard about it. So it was a kind of a co-design and being led to the definition of what the project should be. But it was very much a real collaboration, that it wasn't the chatbot coming up with this app, nor was it the student having a clear picture of what they wanted from the beginning.
So the book has hundreds of these examples where you share the conversation and explanations of how these different apps were created
Right.
in all kinds of different areas: literature, history, mathematics, science.
Right.
About and I think that by sharing these conversations and then having the full conversations online, if people want to go look at them, you're giving people a real smorgasbord, a real taste of all the different things that a student could do working with a chatbot, creating apps about simulations, for example, like this planet one. But I know there's a simulation about ants following pheromone trails. There's a simulation about kelp and otters and with sliders, so you can test what happens when all the kelp goes away. Doing all of that without really any programming knowledge necessary. But if you wanted to, you could look at the code.
That's right. One side project that and there's a chapter about this in the book, was this idea that there's a lot of good reasons to acquire computational thinking, have some understanding of how computational processes are created, how they interact with each other, how they're defined. On the other hand, learning all the technical details means that it's quite a challenge to do it, and it means that you can't be as ambitious because you've got to spend so much time with the technical details. But there's this middle ground, which is where you ask the chatbot to always show you the programs in what computer scientists call pseudocode, which is really just an English kind of simplification of a program. So you're always seeing what the program does, but you don't have to know all the little technical details and the syntax of the programming language, and it's much more readable. So the idea is, if you do want to learn about computation, but you don't have time to learn a programming language in detail, this is a way to learn about computation by building apps, but seeing the pseudocode English equivalent, or actually, I say English, but of course, these chatbots are up to like 80 languages now. So that if you wanted it in Swedish or Hindi, you could get the pseudocode in that, your own
So
favorite language.
I think this way of building apps offers teachers a real wide array of different ways to approach computational thinking. You can approach it from I want the kids to learn programming. You can approach it from, I want them to think carefully about the if-then kinds of sequences that simulations desire. I want them to learn the math behind these simulations. I want them to just play around with the idea of how different systems interact with each other and have that represented on the screen. I think it gives teachers a really wide range of ways that they can have their students approach things that were very difficult to approach previous to this.
Yeah, that's right. An example too of one additional thing, when you're co-designing or creating a simulation, then you could do computational science experiments with your simulation, so that you mentioned the simulation of the, well, maybe I could find it real quick, of the kelp. Yeah, here it is. I don't know. So
And
this
this
is,
was all done just speaking to a chatbot and telling it to make a simulation.
yes, yeah. And what's interesting from the point of view of the underlying science here is that the story behind this is a cute one, in the sense that the kelp forests off of the west coast of the United States were disappearing. And somebody came up with the idea that maybe it has to do with the fact that so many sea otters had been killed for their fur. So they found some sea otters, I don't know, up in somewhere in Canada, and reintroduced them to California. And what they discovered was that it was the sea urchins that were destroying the kelp. And the sea otters were very good at eating the sea urchins. So as soon as there was enough otters, the kelp forest started to grow back. And that's the kind of thing you could experiment with here. You could set up the initial populations and how fast they reproduce, and explore this kind of thing and see the graphs of it as it's unfolding. And you can
So
even
if you
get a
wanted to
little
like
crude sense of the animation of what's
turn
going on.
your otter reproduction rate up really high, you would expect to see them eat all the urchins, right? Something like that.
Yes.
You can play with the sliders and the numbers and test your theory. Is it the otters that are eating the urchins? But where did this data come from?
In this case, it was so in this field of what's called agent-based modeling, where you're modeling interactions of individuals. In this case, the individuals being the kelp, the sea urchins, and the otters. There's two approaches. One is to take a much more abstract approach, which this is which is saying, let's just simplify the biological system such that so we can explore very clearly or effectively. And the other approach, which isn't in contradiction, is to say, let's pull in some real world data and to capture what is the reproduction rate of otters, and how often does an otter manage to eat a sea urchin, and those things. And then you could see how much the system matches what's been observed. So there's two different approaches. This particular one is one where it wasn't data driven. But I did do another big project having to do with the connection between weather and the occurrences of influenza. And that was very data driven, where the chatbot gave me suggestions of how to get data from the CDC and the other sources of weather, and how to massage the data and how to process it. And so you can do data grounded experiments as well as ones that are much more abstract, like this one.
Wow. I think that's a real boon for people who want to get into data science and have kids who are interested in the real world. We always talk about, oh, kids should do these things from the real world, but it's difficult to find all these sources of data and to create models in the kind of specialized model software that exists, but is for graduate students, not high school students. This seems completely doable at a high school level.
Maybe before I show you some of the non-programming examples, there's maybe one more programming example that I'm particularly proud of that I'd like to show here. So,
Oh, I know what this is. This is fun.
yeah. Okay, so if I just move the mouse around, I get these. I could turn on the microphone, Oh, here, maybe I'll even get a few more just to, for what I want to show. Spell AI.
Oh, fantastic.
I don't know why it stopped a little early, but I can do something
I can see it.
else. Yeah, yeah.
I can now understand almost
Oh.
anything you say.
Okay, so now I could say cat. There we go. Dog, yeah. But I can say more things. I could say smiling face, angry face.
So you made this app just by talking to the chatbot and telling it you wanted like a emoji paint program.
Yeah. So this is the very first thing it did, which was just as I moved the mouse, it left emojis behind, but they didn't stick. And then after about 30 more minutes, not only did it stick, but the microphone bigger. We might have troubles with the microphone. Oh, because Zoom is also using the microphone. Bigger. Well, believe me,
Works just
it
like
does
my
work.
my
Oh,
speech interface works most of the time.
Yeah. Yeah, speech is finicky. Anyways, so this was, then the next thing I said was what I demoed, where you can say dog or cat, and then you can add a black hole, which is a feature that's cool. Here's the black hole. And if I click here and I put down the black hole, this is one of these. So, oh, here we go.
Oh, it's
Everything's getting
sucking
pulled
everything
over.
in the black
This
hole.
is gravity. Oh, notice it finally got bigger. So I think what was going on was I had two versions.
You had two browser windows open.
Yeah, well, both of them were listening to what I was saying or something. Another feature that's very popular with my 3-year-old granddaughter is this one. Oh, wait, that's the chase one. That is popular more with my grandson. This is the dancing one. And it's usually playing music. It's actually synchronizing movement to the music.
Funny.
And,
My granddaughter would like this.
yeah. Yeah, there's other
Definitely.
features here.
She loves emojis.
Make things, the horse will make things go faster, and the turtle will make it go slower, and the elephant will make things go bigger. Oh well.
Let's see.
Yeah. Maybe I'll get the black hole to. Okay.
Suck up all the mommies.
Oh, and then again, you could ask the.
Here are some things you can say or do. Black hole to create a black hole, which attracts emojis. Dance to make emojis move and dance to the beat of the music.
Refresh the
You can
page.
also drop an MP3 file onto the app to use your own music for dancing.
Oh,
Okay. So I also wanted to show non-programming apps, even though
Yes.
there's so many interesting programming apps that I'm very proud of. I'll start with this one then. So here's an illustrated story about the proof that there's an infinite number of prime numbers. And I'll show you later how I created this story. And I also interacted with ChatGPT to create all the illustrations. And as you can see, some of them are a bit weird, like there's no mastodon husks that combine like that. Anyways, so here's the story about this prehistoric girl that likes to play with pebbles, and she meets this wise old woman who explains some things about there's difference between whether you can put the pebbles in a rectangle, which is a composite number, and if there's no way to put it in a rectangle, that it's a prime number. They go on and on. And there's a whole chapter in the book about how to deal with the shortcomings of these illustration generating programs, because as you can see, there's not much consistency. It makes a lot of mistakes, but you can still get pretty far and still create something that's pretty interesting.
Yeah, I think writing stories that connect to other areas of the curriculum, like math, is a way for kids to explore areas that they may think are boring. Math isn't often presented in terms of it being a fun story about exploring numbers, and this could have been in outer space, or it could have been any setting.
Right. That's true. I also wanted to show one more example of this, which let me find it here.
So, like Ken said, in the book, there's not just examples of how to do these things, but also how to do troubleshooting along the way, how to deal with some of the not so nice things that chatbots do, like make mistakes in illustrations, which I think a lot of people have seen online, some very funny illustrations that chatbots have made up. If you help kids understand that these chatbots aren't perfect, then they have a role to play with making the story better, with making the story more interesting, with correcting the chatbot. And that's where the learning happens.
The co-writing together. There's so many different ways in which you could write together with a chatbot, where you could have a draft. It could give you comments. You could go back and forth. You could do every other. You could write some back and forth. You could have it write something, but then you start to give it critical feedback and it revises it, and you're acting as the role of an editor and less of a writer, all these things. Well, what I wanted to show just here was a way in which all these different generative AI programs can be combined in a way that where the students can learn a lot about generative AI, but they also learn about the subject matter. In this case, once again, the proof about the primes. But well, let me show it to you and then talk about it.
I've been thinking about numbers, both big and small. But there's one type of number that stands tall. Primes, oh primes, they're quite sublime. And I'll prove to you why they'll never decline. Suppose there's a limit, final prime. That would mean all primes are defined. But I've got a trick to make you see that primes go on indefinitely. Take all the primes, multiply them, add one to the product. Now isn't
I'm going to stop it just because it's like 3 minutes long. But here's the post I made about how I created it, what I prompted to get the lyrics, and then how I kept going back and forth and then trying to get it to make these nice illustrations. And then once I had all the illustrations, try to put it together in an app, and then how to get another program to generate the song and how to describe what style you wanted it all, putting it all together. It's this whole project was less than a day, and it could, of course, been students could work as a team where some of them work on the lyrics, some of them work on the song, some of them work on the illustrations and putting it together, and others can make sure that the mathematics is correct and so on. So there's a possibility to do some really interesting kind of multimodal things by combining the outputs of these different generative AI programs, and then to finally put it all together was really pretty straightforward. It's just to ask a chatbot to say, okay, I've got these 5 images, I got this song, and I want to display it this way. And it created the app that we just saw.
It made this little slideshow with the music, and the kids could have sang the song in front of the class. I know in the book, there's a play, like a courtroom drama about the same subject. There's an epic poem. There's jokes and riddles about the same topic. Any topic can really create a lot of different ways to express the idea of this one mathematical proof. So I think for a lot of teachers, AI seems like, oh my God, it's just making stuff that then what am I going to have to grade it? And the kids didn't even make it themselves. I think there's a different way to look at this, is that this, I think, solves problems in the classroom where we want kids to play around with different ideas. We want kids to play around with the big ideas of mathematics or science or history. And the chatbot is a fun playmate for this.
That's right. And the way I think teachers should approach this is to value at least as highly the student's description of the process of how they interacted with the generative AI to create what they created, as well as if they created something that's high quality, that where the students did some checking to make sure that there weren't some hallucinations or incorrect things, because chatbots aren't 100% reliable, but that could be turned into a learning experience if the students are expected to fact check or to make sure that what they produce, the final product, is correct. So, but maybe this is a good segue to the idea that you could do projects that are all different scales. Some of these took 10 minutes. The emoji adventure thing, where it had the black holes and the dancing and the chasing and everything, that took a week. So there's quite a range of scales of projects.
Classic project-based learning is that the projects can rise to the level of student interest, students' ability. It's always about the process, not the product. So to me, this completely fits with the theory of constructionism that leads many teachers to understand how project-based learning works, and that this fits well into that. It shouldn't be banned from classrooms. It should be a tool that kids are allowed to explore, that kids are the master of, not that the AI is going to take over and do everything for us.
Yeah, this is a lesson I learned from Seymour Papert and Marvin Minsky 50 years ago. Seymour had been a colleague of Piaget and had worked with him for a few years in Geneva. And both of them were very much into the idea that the important kinds of learning is where you're not acquiring facts, you're instead constructing knowledge, you're constructing in your head the way things interact, the different pieces, putting it all together. And that led Seymour to later come up with his theory of constructionism, which builds on Piaget's constructivism, which adds the idea that you not only a really effective way of learning by constructing knowledge is in the process of constructing some artifact, and one of the better kinds of artifacts are computer programs, because they have all these editability, they're dynamic, they can embody computational thinking ideas. There's so much of the book where I keep connecting up the ideas from constructionism and project-based learning to different activities and how it fits together.
So do you want to show a little bit of the adventures and stories?
Yeah, I do. Well, here's a very simplest thing, which is asking the chatbot to simulate personas. And these personas typically are famous people, like here it's Aristotle and Galileo, where I'm saying, can you simulate a conversation between them in such a way that after every exchange, I can add something to the conversation? But it's important to realize that it doesn't have to be people. It could be ideas. It could be animals. It could be all sorts of things that you could have conversations with. But what happens is Aristotle and Galileo have this polite discussion about heliocentric versus geocentric views of the universe. But I pop in and say, well, I want to hear about gravity. And then they come back with it. And then they each have their different ideas. So I ask them what evidence they have, and they talk about this. And then I try to say, well, what's the connection here? But at some point, I pretend to be the student, realize that neither Aristotle nor Galileo really has a very good understanding of gravity. So I say to ChatGPT, could you bring Newton to this conversation? And Newton comes in and explains his theory and how and then they react to it. And just a little conversation like this, I think, could be a great learning experience, and one that's much more engaging than just reading about what Aristotle's mistaken ideas about how heavier objects fall faster and how Galileo questioned that, and then how Newton came up with a more general view of what's going on. That this makes it engaging, but also more interactive. You could ask questions, you could engage with the conversation. So that's one of the simpler kinds of experience, kinds of things. So this one is one of these.
This is the entire prompt. The
this is the entire prompt.
knows
right
it
here.
knows what a adventure is. It knows what a text-based adventure is. You don't have to explain
yeah.
the game mechanics to it.
Yeah. The only thing that was added to make the game mechanics work better was the usual way in which these text-based adventures worked was you would get 4 or 5 options and you would say 1 or 3, and then you would do that action, and then the program would show how the environment or the world
Right.
reacted
I
to
I want to
that,
go to the
and then
market.
describe the new.
Yeah.
Yeah. And it does that, but I said, including any custom action, because these chatbots could understand anything, unlike the old ones. And unlike the old adventure games, this is completely open-ended. This is unfolding on the fly as you just asked for it. If I hadn't said Julius Caesar's assassination, instead I said a visit to ancient Athens, you would get a very different adventure.
Mhm.
So in here, I said somewhere to an accompanying image.
Mhm.
So here's how it starts. It shows this nice picture of ancient Rome, and there you are, the students seeing this. And it says you're a student who's gone back in time to 44 BC. And so it gives you these 4 options. And at first, I just said 2, talk to the local people. And it says you go up to somebody and ask them what their opinion
Well,
is.
that's a classic text adventure game,
Yes,
but
exactly.
it's
Except
happening
again,
real time. It's happening on the fly in real time.
That's right. That's the big difference, is that it's the students in control of it, and it wasn't pre-programmed carefully by some programmer. It's just the chatbots making it up as we go. And so again, I pick number 3 here, and we get another illustration and more going on, and we're hearing from what some of the people are saying. And I pick another one. I say, I want to go to the Senate House. But at one point, I start to go off script. Let's see. So this is funny that you're supposed to be hiding behind the pillar to watch the assassination or something.
Hiding everyone's sight line, I guess. It's
Right. Okay, but here's where I go off script in some sense. It's saying, okay, now that you've seen the assassination, what do you want to do? And I pick one. I said, well, let's just talk to people a few days later. And you go around.
And it just
you
goes
meet
with
people. Yeah, it just goes with it. And I hear more about that. And then I say, okay, what are people saying a year later about it? And you can choose whether the people you talk to are politicians or soldiers or commoners or something. So it was quite an interesting exploration. And I did something funny at the very end here, which is after it was over, I said, okay, how accurate is Shakespeare's play? And of course, I didn't have to say his play called Julius Caesar, because that was the whole context of this discussion.
figured it out. It
And
knew what you meant.
And it figures it out. And it gives a pretty interesting thing. The historical events, he compressed some and he altered some timelines to make a little, but it's mostly right, it sounds like, what themes he was exploring and so on. So that was quite a nice example of a adventure. And I've had lots of other adventures where you're exploring moral dilemmas or learning French science fiction adventure or all sorts of
That's the learning
So-
French one is very interesting because you could have as easily said, do this whole adventure in French and make me respond correctly in French. And it would have been something pretty interactive for a foreign language class.
Yes. As a matter of fact, I mean, maybe I won't show it exactly here, but that.
Also in foreign language, I know there's a part in the book about word games. Any of the word games, even something simple as a word search, could be done in French or Japanese or anything. It will make
Yes.
interactive games in any language.
That's right. So I found the French one, so I start off saying I've only studied a little bit of French. I'm a high school student, but I like science fiction, and asking again but unlike, it says, don't list possible actions. Let me come up with them and then point out any mistakes I make. And it starts off with this thing that I found too difficult. So I just said, this is too hard. And it comes up with a little simpler French language. And then I wanted to speak with the scientific officer, but I couldn't really remember very well how to do it. And what I thought was so interesting was it says, oh, you decide to speak with your officer scientific. But notice I had said, put them in the wrong order, and I said this instead of avec. So uh, it was gently correcting me by repeating what was said, but
Which is
incorrect.
exactly what you're supposed to do with language learners is you just repeat what they say correctly and gradually they understand.
Yeah, and it goes on and it makes an illustration of what's happening in the story. And at one point, I couldn't figure out what somebody was saying. So I asked for a translation, but mostly I was doing everything. Yeah. Yeah, here I said, I don't really understand what he was saying. And then it did this little translation or something. So I'm sure that if, as I remember my French lessons in high school, this would have been a really appealing way for me to practice my French, to have adventures like this. And the latest versions of ChatGPT, you can be doing this spoken so that you could be
Mm.
talking the French and listening to the French and have it also correct not just your French grammar or vocabulary, but even your accent, maybe your pronunciation.
I think that's one of the points you keep making in the book is these chatbots keep getting better and better. And the things that they're able to do are going to astound us. But the basic ability of using a chatbot to create experiences and adventures and simulation, that's not going to change. So I think this book will be more able to stand the test of time than some of the other AI and education books that just explain exactly what to do today.
Right. Yeah. So even if these chatbots keep getting better and better, the underlying idea that you should be collaborating with them, having conversations, not just try to ask them for something and then just accept the result. That instead, it has to be this back and forth where student can be playing different kinds of roles. If it's creating an app, they could be more the designer, or they could be the critic or the tester, or they could be doing some of the programming. And when they're writing, they could do the writing and get feedback, or they could be the editor and giving feedback to the AI as it does writing. All these different combinations of different roles and ways of interacting are going to continue even as the chatbots get smarter and smarter.
Well, I hope
Capable.
people listening to this understand that these are just a few, very few examples of what's in this book. There's a wide range of apps, there's a wide range of adventures and how to create stories, and that there's really something for everyone here, including some ways to make the chatbots work more efficiently for you. Maybe you can talk a little bit about like some of the custom GPTs and the ways to control what chatbots can do.
Right, right. So there's a lot of talk of something called prompt engineering, where the idea is that you create a long, complicated prompt that tells the chatbot exactly everything you want. What are the constraints? What's your goals? What style you want it to have? It just goes on and on with that. And there's some context where that's valuable, but there's also lots of times where you just start with a sentence and then you expand more what you want and you maybe explain more. And if it describes things in too technical language, you say, I don't understand that. Use a simple language, all this kind of back and forth. And there's, for a lot of school uses, the book does have chapters talking about how you could give an initial guiding prompt that isn't so much telling the chatbot what the project is or the task is, but more setting up the whole context, the style, pedagogical style you want, the tone you want, the language level you want, those kinds of things. And maybe a little bit about how you want to interact. And you might want to tell it to
Maybe the age of the student or something.
and
So it's
ask them what thing to ask them if they've got an idea. If their idea is too complicated, discuss how you start with a simpler version of it. If they don't have an idea, ask for interest. You could set up the kind of instructions, and you just do it in English. It's not like you need to have any special technical skills to give those. And then many of these chatbots have the ability to encapsulate all of that advice in what like OpenAI calls a custom GPT, or I think In Claude, they're called projects, and Google's Gemini, they're called gems, but the name isn't important. The idea is that you end up with a URL that kind of already starts off the chatbot with the guidance that you want. And then the student could start their conversation with a chatbot that's customized the way a teacher might want. So
I think that could be really useful in a classroom situation, because even though you might start with these custom GPTs, every experience the student has is going to be completely different, because the chatbot says something different every time you ask it. Even if you say exactly the same thing, it'll come up with something different.
That reminds me, there's a chapter that I think it is important, but I think is too often overemphasized, which is from the point of overemphasized in the context of schools, which is how do these chatbots work? So there is a chapter that talks about how they're trained and how their transformers work, all this, and tries to do it in a very non-technical way with pointing to some interactive apps for exploring these things. But there's a lot of people that are focused on AI literacy, of trying to get teach children about AI rather than how to use it. And to me, that the balance is all off. It's important, but my view is that should be 5 or 10%, not 90% or something, of talking about how the AI itself works.
Yeah, I think there's the AI literacy overemphasizes the how it works, why it works, ethics, all important things. But if you're not using something, you don't really understand what you're talking about. It has to be both. You
Yeah.
can't just have chemistry lab safety rules. You have to actually try some experiments. We're always talking about hands-on, and it's hard to imagine that in a computer sense, but we're talking about the same kinds of hands-on experiences. You have to get your hands dirty with AI to understand what it can and can't do. And then the lessons about how it works and ethics, and that makes sense. So we have to give teachers, and this is what I hope the book does, is it helps teachers make the case for this creative use, because it both has to happen in schools. We have to give teachers the ability to see what's possible with their students, so that they can go and say, we shouldn't be banning this. We should be experimenting with it. We should have an R&D lab at our school for us to make our own decisions and have kids make their own decisions about what AI can and can't do. And the student's experience is crucial in this. We can't just tell them how they're supposed to live in the world. This isn't going away.
No, there's the slogan now that people that are going to lose their jobs are the ones that aren't using AI in their work, but that the ones that are succeeding, whether they're lawyers or doctors or whatever, are taking advantage of AI instead of thinking of AI as replacing people's work. It's because it can augment their capabilities so much. It's only the people that take advantage of them that are going to succeed, and the ones that stay away from the AI are the ones that might be in trouble.
Yeah, we can't stop this progress. AI are going to be embedded in tools. It's going to be embedded in our daily life. It's better that we give kids the keys to understand that they have control of these things, and they are capable of understanding how they work and what it means. And then they can decide if they don't want to use AI, that's fine. But there's a number of things you can do with AI that are interesting. And I think that this book is an invitation for teachers to experiment and to come to their own conclusions, and help young people experiment as well. That this isn't cut and dry. We don't know what all this is going to mean to schools, but what we hope it's not that some AI is going to offer automatic tutoring and replace teachers. That's not the kind of future that we want to see. And I don't think it would work. I just don't see that. I think people are blaming AI for a lot of things. it's no shock that if you give an assignment that you can Google the answer, kids are going to Google the answer. And if you give an assignment that you can ask AI to do, some people are going to use AI to do it. And yeah, they're not going to have the learning experience you hope, but it's up to us to rethink the kinds of things that we ask kids to do and that we ask kids to participate in so that they can take advantage of the world that exists today and that's going to exist when they grow up.
Right.
So I think that what I hope people get from this interview is that there's actually a lot more in the book than we've been able to show in this time frame. And on the CMK Press website and in the newsletters that we send out to our subscribers, we're going to be describing lots of the things that you can do with AI and that are explained in the book. And we hope people try it. We hope people get the book and give it a try and let us know how it goes.
I should maybe say one of the things that motivated me for writing the book
Mhm.
goes back to when I first learned about computers and how empowering they are and how they're almost magical in the way that you could have an idea and turn it into something that is interactive, that becomes alive in some sense. That it's now even easier to do that, but easier doesn't mean that there's less learning. Instead, what I believe is that students now could be much more ambitious. They could create much more elaborate projects and many more of them and explore the space. So I'm excited about enabling that kind of creativity and curiosity and exploration that chatbots enable, but get across to students and teachers and parents that this is a potential that's only appeared in the last 2 or 3 years.
I think this is an interesting time we live in, and teachers that have the inclination and the curiosity to experiment with these things are just amazing and wonderful. And we encourage that curiosity about the world. The kids are going to do all kinds of things that we don't anticipate, and that's a good thing. That's what we hope for all students, is that they surprise us with the amazing ideas that they have.
Mm-hmm. That's right.
So I'm going to wrap this up, and we hope that everyone takes a look at the book on cmkpress.com. It's called The Learner's Apprentice, AI and the Amplification of Human Creativity by Ken Kahn. So thank you, Ken, for your time, and we will talk again soon.
Great. Enjoyed this. Good. Bye.
Thank you.
Get your copy of The Learner's Apprentice, AI and the Amplification of Human Creativity today at Amazon.com.